All right, let's go. Number 10, Uranus, the 42-year night. In our own solar system, there is a planet that has effectively abandoned the normal rules of orbital mechanics. Uranus is the seventh planet from the Sun, an ice giant composed of water, ammonia, and methane fluids over a small rocky core. But what makes Uranus truly unsettling is its axial tilt. While Earth tilts at a modest 23.5 degrees, giving us our gentle rolling seasons, Uranus is tilted at a staggering 98 degrees. Sometime in its ancient past, an Earth-sized object slammed into the planet with such catastrophic force that it literally knocked the entire world onto its side. It now orbits the Sun rolling like a barrel rather than spinning like a top. Because of this extreme orientation, the concept of day and night on Uranus becomes an exercise in profound endurance. The planet takes 84 Earth years to complete a single orbit around the Sun. For the regions near the poles, this creates a day-night cycle that defies human comprehension. If you were to stand at the North Pole of Uranus, you would experience 42 Earth years of continuous, unbroken daylight. The sun would never set. It would simply trace slow, concentric circles in the sky, rising higher for 21 years before slowly sinking over the next 2 decades. Then comes the twilight, followed by 42 Earth years of absolute freezing darkness. An entire human lifespan could pass within the span of a single Uranian night. The psychological terror of enduring decades of total blackness is matched only by the physical extremes it generates. During the 42-year night, temperatures plunge to minus 224 degrees Celsius, making it the coldest planetary atmosphere in the solar system, even colder than Neptune, which is further away. What makes this cycle particularly violent is the transition. When the sun finally reaches the equator during the brief Uranian equinox, the sudden influx of solar radiation into an atmosphere that has been frozen in darkness for 4 decades triggers massive, planet-wide storms. Telescopes have observed clouds the size of continents erupting in the atmosphere, driven by winds howling at 900 kilometers per hour. On Uranus, day and night are not merely periods of light and dark, they are generational epochs of frozen stagnation, violently interrupted by catastrophic weather. Number 9. Venus, the day longer than a year. Our closest planetary neighbor is a world of absolute horror. Venus is often called Earth's twin because of its similar size and gravity, but its environment is a toxic, crushing hellscape. The surface temperature hovers at 475 degrees Celsius, hot enough to melt lead, and the atmospheric pressure is 90 times that of Earth, the equivalent of being a mile underwater. But beyond the acid rain and the suffocating heat, the temporal mechanics of Venus are entirely broken. Venus has a retrograde rotation, meaning it spins backward compared to almost every other planet in our solar system. If you could see through the dense sulfuric acid clouds, the sun would rise in the west and set in the east. But the true anomaly is its speed. Venus rotates incredibly slowly. It takes 243 Earth days for Venus to complete a single rotation on its axis. However, it only takes 225 Earth days for Venus to complete an orbit around the Sun. This creates a mathematical nightmare. On Venus, a single sidereal day is actually longer than its entire year. Due to the combination of its backward spin and its orbit, a solar day, the time it takes from one sunrise to the next, lasts for 117 Earth days. You would experience nearly 60 Earth days of continuous, blazing sunlight, followed by 60 Earth days of darkness. But what makes the Venusian night truly terrifying is that it offers absolutely no relief. On normal planets, the dark side cools down, radiating heat back into the void of space. But Venus's runaway greenhouse effect is so efficient, and its atmosphere is so thick that the temperature at midnight is exactly the same as the temperature at noon. The atmosphere itself refuses to abide by the planet's slow rotation. While the solid ground barely crawls, the upper atmosphere whips around the entire planet in just 4 Earth days, a phenomenon known as atmospheric superrotation. This creates hurricane-force winds in the upper cloud decks that never cease. If you were trapped on the surface, time would lose all meaning. The 60-day night provides no cooling, no shift in the relentless pressure, and no break from the oppressive reality of a world that has essentially forgotten how to rotate. Number 8. Proxima Centauri b, the eternal twilight. In 2016, astronomers made a discovery that transformed the search for alien life from distant speculation into a local reality. Just 4.2 light-years away, orbiting the closest star to our solar system, lies Proxima Centauri b. It is a rocky planet situated perfectly within the habitable zone, the region where liquid water could theoretically pool on its surface. But habitability around a red dwarf star comes with a severe structural compromise. To receive enough warmth from the dim, cool red dwarf, Proxima Centauri b must orbit incredibly close to its host star, completing a full revolution in just 11 Earth days. At this extreme proximity, the gravitational relationship between the star and the planet changes. The immense tidal forces act like a planetary brake, locking the world's rotation to its orbit. This phenomenon, known as tidal locking, means the planet takes exactly the same amount of time to rotate on its axis as it does to orbit the star. The result is a world where the concept of day and night ceases to be a cycle and becomes a permanent geographic location. One hemisphere of Proxima Centauri b faces the star in an eternal, unbroken day. This day side is endlessly scorched by the sun, battered by intense stellar flares, and bathed in perpetual red light. It could be a boiling ocean or an irradiated desert. The other hemisphere faces the endless void of deep space. Here, the night lasts forever. Temperatures likely approach absolute zero, and any atmosphere might freeze out into vast glaciers of solid gas. Between these two extremes lies the Terminator line, a narrow ribbon wrapping around the planet where the sun is perpetually sitting exactly on the horizon. In this zone of eternal twilight, conditions might be just right for liquid water and, potentially, life. But the environment would be deeply unsettling. A permanent hurricane would likely roar across this boundary as hot air from the day side rushes into the freezing vacuum of the night side. Any biology evolving here would never experience a sunrise or a sunset. They would live in a narrow corridor of perpetual dusk, sandwiched between a hemisphere of eternal fire and a hemisphere of eternal ice. Number 7. Mercury, the double-year day. Mercury, the innermost planet of our solar system, is a world scorched by its proximity to the sun. For a long time, astronomers assumed Mercury was entirely tidally locked, believing one side always faced the sun while the other was cast in eternal shadow. But in 1965, radar observations pierced the glare of the sun and revealed a much stranger truth. Mercury operates on a highly specific mathematical trap known as a 3-to-2 spin-orbit resonance. The planet rotates exactly 3 times for every 2 orbits it makes around the sun. When you combine this bizarre rotational gearing with Mercury's highly elliptical orbit, the behavior of the sun in the Mercurian sky becomes surreal and torturous. Because the orbit is so oval-shaped, Mercury's orbital speed changes drastically. When it approaches perihelion, its closest point to the sun, it is whipping around the star faster than it is rotating on its axis. If you were standing in the Caloris Basin, one of Mercury's largest craters, you would witness an impossible dawn. The enormous sun, appearing up to 3 times larger than it does from Earth, would rise above the horizon. But as the planet accelerates along its orbit, the sun would appear to stop in the sky. It would then slowly move backward, dipping toward the horizon it just rose from, before stopping again and resuming its normal path across the sky. Because of this celestial dance, a full solar day on Mercury, from one sunrise to the exact same sunrise, takes 176 Earth days. That is precisely 2 Mercurian years. The environmental impact is devastating. The surface is subjected to months of relentless, unblinking solar radiation, driving daytime temperatures to 430 degrees Celsius, hot enough to melt zinc. Then comes the long night, lasting for months, where the lack of atmosphere allows all that heat to escape instantly into the void. The dark side plummets to minus 180 degrees Celsius. It is a world where a single day-night cycle is an ordeal spanning 2 entire years, swinging between absolute incineration and deep space freezing. Number 6. KELT-9b, the day that destroys matter. When we think of long days, we usually imagine sunlight and heat, but on exoplanet KELT-9b, the concept of day becomes a zone of physical and chemical annihilation. Discovered in 2017, KELT-9b is a gas giant located roughly 670 light-years from Earth. What makes this world an astronomical nightmare is its host star, a massive, blazing blue A-type star that burns nearly twice as hot as our own Sun. Like many planets orbiting incredibly close to their host stars, KELT-9b is tidally locked. One hemisphere is doomed to face the blinding blue inferno forever. Because it orbits so tightly, completing a year in just 1.5 Earth days, the permanent day side reaches a temperature of 4,600 Kelvin. To put that into perspective, this planet's day side is literally hotter than the surface of most stars in the galaxy. At these incomprehensible temperatures, the very laws of chemistry begin to break down. The thermal energy blasting the day side is so intense that molecules simply cannot exist. The heat violently rips apart hydrogen gas, severing the atomic bonds and reducing the atmosphere to a chaotic soup of individual, dissociated atoms. The day side isn't just hot, it is a permanent state of molecular disintegration. But the horror doesn't stop there. The immense heat creates extreme atmospheric pressure differences, driving supersonic winds that sweep these torn-apart atoms toward the permanent night side. As the atomic hydrogen crosses the terminator line and enters the darkness, the temperature drops slightly. In this cooler environment, the atoms are finally able to recombine back into hydrogen molecules. But when atoms recombine, they release all the energy that was required to tear them apart in the first place. The night side is continuously bombarded by massive amounts of explosive thermal energy from this recombination, keeping the eternal night at thousands of degrees. On KELT-9b, the day breaks matter apart, and the night violently pieces it back together in an endless cycle of atomic destruction. Number 5. Trappist-1e, the eyeball world. In 2017, the scientific community was stunned by the announcement of the Trappist-1 system, a collection of 7 Earth-sized planets orbiting an ultra-cool red dwarf star just 40 light-years away in the constellation Aquarius. Because the star is so dim and cool, its habitable zone is pulled inward, incredibly close to the star itself. The entire Trappist-1 system would comfortably fit within the orbit of Mercury. Consequently, all 7 planets are tidally locked, facing their star with a single, unblinking hemisphere. Trappist-1e sits perfectly in the center of the habitable zone, making it one of the prime candidates for alien life. But what would life look like on a world where day and night are permanent geographic fixtures? Planetary climatologists have modeled exactly how Trappist-1e might function, leading to the chillingly named eyeball planet hypothesis. If the planet has oceans, the permanent night side would be a wasteland of solid, miles-thick ice, locked in total darkness and frozen at temperatures far below zero. The permanent day side, directly facing the crimson heat of the star, would feature a vast, deep ocean of liquid water. From space, the planet would literally look like a giant eye, a dark, icy pupil surrounded by a liquid iris staring eternally at its host star. The atmospheric dynamics of an eyeball world would be chaotic. The subsolar point, the exact center of the day side where the sun is directly overhead, would receive the maximum amount of stellar radiation. The water here would constantly evaporate, creating a permanent global cyclone. A massive, eternal hurricane would sit at the center of the day side, dragging in cold air from the frozen night side and distributing immense amounts of heat and rain. If intelligence were to evolve in the oceans of Trappist-1e, they would possess no concept of time as we know it. There are no seasons, no months, no sunrises, and no sunsets. The sky never changes. To travel from day to night isn't a matter of waiting, It is a perilous journey across the globe from an eternal storm into a lightless, frozen abyss. Number 4. Corot 7b, the magma ocean. Located roughly 480 light-years away in the constellation Monoceros, Corot 7b is a rocky exoplanet about 5 times the mass of Earth. It was the first super-Earth to have its radius accurately measured, proving that rocky worlds exist outside our solar system. But any hope of habitability was instantly crushed by its orbital mechanics. Corot 7b is parked agonizingly close to its sun-like star, completing an entire orbit in just 20 Earth hours. Unsurprisingly, the gravitational death grip of the star has tidally locked the planet. The permanent day side is subjected to a stellar bombardment so intense that the surface temperature reaches an estimated 2,500 degrees Celsius. This heat completely fundamentally alters the state of the planet. The sun-facing hemisphere is not made of rock. It is a global, churning ocean of liquid magma. The day side is literally a hemisphere of boiling liquid fire. Because the heat is so extreme, the atmosphere on the day side is completely alien to human understanding. The magma evaporates, filling the sky with vaporized rock. Clouds of gaseous silicate drift above the molten ocean, pushed by immense thermal winds toward the dark half of the planet. As this rock vapor atmosphere crosses the terminator line and enters the permanent night side, the nightmare transforms. The night side is entirely hidden from the star's heat, plunging into freezing temperatures. As the gaseous rock hits the cold air, it condenses rapidly. High in the twilight sky, it forms liquid droplets of magma. As these droplets fall, they solidify into solid stone. On Corot 7b, the transition from day to night means passing through weather systems where it rains pebbles and snows solid rocks. The permanent night side is an expansive, frozen wasteland of stone, buried under billions of years of accumulated rock snow, forever hiding from the eternal magma ocean on the other side of the world. Number 3. WASP-12b, the doomed day side. Not all endless days are merely hot. Some are fundamentally destructive. WASP-12b is a hot Jupiter located 870 light-years from Earth in the constellation Auriga. It orbits its host star at an astonishingly close distance of just 2.1 million miles, which is merely a fraction of the distance between Mercury and our Sun. Like all planets in this proximity, it is perfectly tidally locked. The day side is forever facing the star, baking at 2,500 degrees Celsius. But what makes WASP-12b uniquely terrifying is that its permanent day is acting as its executioner. The planet is so close to its massive host star that it has crossed a critical threshold known as the Roche limit boundary. The gravitational pull of the star is overwhelmingly stronger on the day side of the planet than on the night side. This immense differential in gravity is physically stretching the entire planet out of a spherical shape and warping it into a massive, distorted egg. The day side of WASP-12b is literally being ripped away. The gravity of the star is stripping the superheated atmosphere right off the surface, pulling billions of tons of matter into the void. This material spirals inward, creating a glowing accretion disk of planetary flesh that slowly feeds the ravenous star. The eternal day on WASP-12b isn't a climate. It is an ongoing state of physical unraveling. Astronomers watching this system have calculated a grim timeline for the planet. WASP-12b is losing mass at such a catastrophic rate that it will be entirely consumed by its star in approximately 10 million years, a mere blink of an eye in cosmic terms. The eternal day side is a front-row seat to an unavoidable apocalypse, where the dawn never ends, but simply pulls you closer and closer into the fires of oblivion. Number 2. Rogue planets, the eternal night. We define a day by the rising of a star, and we define a night by its setting. But what happens when you take the star away completely? In 2013, astronomers discovered PSOJ 318.522, a free-floating planetary mass located 80 light-years away. It is a rogue planet, a world completely untethered to any solar system, drifting blindly through the vast, empty ocean of interstellar space. Planetary formation is a violent, chaotic process. As gravity pulls gas and dust together to form planets, their orbits often destabilize one another. Billions of years ago, through gravitational interactions with larger planets or passing stars, worlds like PSOJ 318.522 were violently ejected from their home systems. They were cast out of the light and flung into the cosmic void. Astronomers now estimate there could be billions, perhaps trillions, of these wandering orphans quietly drifting through the Milky Way. For a rogue planet, the concept of day is a forgotten memory. Their reality is one of eternal, unyielding night. There is no dawn coming, not in 100 years, not in 1,000,000,000 years. The surface of a rocky rogue planet would be a frozen tomb, wrapped in pitch-black darkness, with temperatures hovering just a few degrees above absolute zero. Yet, within this eternal night, a terrifyingly resilient form of habitability might exist. While the surface is frozen, the deep interior of the planet could still be hot, warmed by the radioactive decay of heavy elements in its core. If a rogue planet possessed a deep ocean covered by a thick shell of ice, geothermal vents on the ocean floor could pump heat and chemical energy into the water. Deep beneath the eternal night, alien ecosystems could thrive in the crushing, lightless depths. What makes this deeply unsettling is the isolation. If an intelligent species evolved in the warm subsurface ocean of a rogue planet, their entire universe would be a dark, watery cave. They would have no concept of stars, no awareness of galaxies, and no comprehension of light itself, existing entirely unaware that the rest of the universe even exists. Number 1. Gliese 667cc, the Triple Sun Day. Sometimes the universe breaks the concept of day and night by providing entirely too much light. Located 23.6 light-years away in the constellation Scorpius, Gliese 667cc is a super-Earth that sits comfortably within the habitable zone of its host star. Because that host star is a dim red dwarf, the planet must orbit close enough to become tidally locked. Under normal circumstances, this would mean one side faces eternal day and the other faces eternal night. But Gliese 667cc does not orbit alone. Its host red dwarf is merely the tertiary member of a complex triple star system. While the planet is gravitationally locked to the red dwarf, two other stars, Gliese 667a and b, a pair of bright orange and red dwarfs, orbit the outer edges of the system. If you were to stand on the day side of this planet, a massive, unmoving red sun would dominate the sky, casting a permanent crimson glare over the landscape. But the true astronomical nightmare unfolds on the so-called night side. As you cross the terminator line into what should be freezing darkness, you are instead bathed in the light of the two distant companion stars. From the surface of the night side, you would witness these two distinct suns tracing complex, highly erratic paths across the sky as the planet orbits the primary star. The landscape would be painted with splitting and multiplying shadows. Because these two outer stars are further away, they wouldn't provide the scorching heat of the primary sun, but they would provide enough illumination to banish the true darkness. On Gliese 667cc, the binary distinction between day and night shatters completely. One hemisphere is trapped in a frozen gaze with an immovable red sun, while the other hemisphere spins beneath an ever-changing celestial clock of multiple distant stars rising and setting out of sync. It is a world where shadows are never singular, where the sky is a chaotic canvas of stellar mechanics, and where the soothing rhythm of a simple sunrise has been replaced by a dizzying cosmic display. I'll be sharing more similar videos in the future, so subscribe to stay tuned.